All right, here's a calculus problem, calculus 2. We're going to solve this integral with a trig substitution. Now, let's say that you didn't know you were solving with a trig substitution. What would you look for to determine whether or not you want to use it? Well, first of all, there's a radical symbol here. A lot of students say, oh, I can factor that, and so I can use partial fractions, but partial fractions only works when you have a rational function. And a rational function is a ratio of two polynomials. That radical symbol forces that guy to not be a polynomial. So the denominator, not a polynomial, not rational, no partial fractions. So if we're going to use trig substitution here, and regular substitution doesn't work either, because if I let this guy be u, there's no x to take care of the derivative there. So we have to use a substitution, which means that I have to complete the square on that quadratic down there. So I'm going to do this. I'm going to rewrite it with the x squared term in the front. And then factor out that negative. Because most students, that's where the trouble comes in, is that negative drives them nuts. So I have to add a term here so that these first three terms are a perfect square. And then I have to take in the minus 3 and the plus whatever, or subtract off whatever that is. Oh, this actually, if I factor out the negative, this should be plus. Okay. So I added it to there, and I subtract it from here, and we should keep the same value. So what number goes in here? I have to take this coefficient of the x term, divide by 2, and square it. And that number turns out to be minus 2 squared, which is 4. So I have to add 4 and subtract 4 in order to keep this the same. Now I just take a look at this bit in here. That's supposed to be a perfect square. So if I factor that, that's going to be x minus 2 quantity squared, and then I take 3 and add negative 4, and that gives me negative 1. So there's my completing the square all finished. Now I do have to go back and redistribute that negative in. So I can write that as minus x minus 2 squared plus 1, or better, 1 minus x minus 2 squared. Now students may say, why did you do that? Well, because I don't like the negative sign up front. And when we use trig sub, we actually want it with the 1 first. So now that I have that all done, I'm going to start my problem over and make my proper substitutions. So I'm going to integrate 1 divided by square root of 4x minus 3 minus x squared dx, which after using trig what is this called? Completing the square, I can write this as 1 minus x minus 2 squared dx. Now, what we learned in class, if I have something squared minus something squared, minus, this minus sign right here is the key, I'm going to let x equal sine of t. Now, because of that 2, I don't want that 2 there. So if I add 2 here and then make my substitution, that 2 and that 2 will cancel. So if I let x be sine t plus 2, then dx, the derivative of sine is cosine t. The derivative of 2 is 0. So that's what I have there. So making the trig sub. In for x, I'm going to write x sine t plus 2. And then I have to subtract 2 and then square the result. And then dx becomes cosine t dt. Straight substitution, you go from x's to t's. Oh, sorry I left that off, guys. Hopefully you heard what I said. There you go. Sometimes I don't look up all the time. So if I continue, this is going to equal the integral of cosine t divided by, now those 2's cancel. So down here I'm left with 1 minus sine squared t dt. Continuing on, I'll pay more attention here. Now I know by Pythagorean identity that 1 minus sine squared t is cosine squared t. And again, it's still all underneath the radical. Continuing to simplify, the numerator still stands at cosine t. The denominator can be simplified to cosine t. Now, of course, these will cancel and force me to say that this integral is 1 dt, which, after integrating, becomes t plus c. But however, I started in x's, I have to end in x's. So that means I have to take this guy here, and solve for t to substitute back in for the t here. Solve, oh man, sorry guys. Solve for t. So that means I'm going to subtract 2 from both sides. And then I'm going to take the arc sine of both sides. And that's going to go directly in here. So my final integral solution, or antiderivative, is arc sine of x minus 2 plus c.